The telephone number to call the program is 866-253-2277. That's 1-866-253-CARS. Or visit the show online at americascarshow.com. Here again is Tom Torbjornsen.
And as promised, the president and CEO of NanoSteel Corporation, Dave Paratore, joining us from his office in, I don't know where you are, Dave.
Morning, Tom. Providence, Rhode Island.
There we go. Providence, Rhode Island. How are you this morning?
Not too bad. How you doing?
Well, I'm doing great, thanks. There was really no need for an elaborate introduction here because I've been talking about you and your company's breakthrough for the last 15 minutes. So, everybody's well-versed on what you do and what your company has done. So it's great to have you on the show. Thanks for making yourself available. Greatly appreciate it. NanoSteel, breakthrough, lightweight steels, which are going to be, according to GM Ventures capitalist president, a game changer. Talk about it.
That's the idea. It all comes down to making cars lighter, and so
previously it was thought the only way to do that was via the use of carbon fiber and aluminum.
Yeah, great point. So they certainly get a lot of press. Carbon fiber and aluminum. You get lots of people talking about them, and if you didn't spend too much time digging into it, you'd think that was the answer for everybody. But unfortunately, every answer comes with a set of problems, and with aluminum, carbon fiber, those are going to be tough answers for your average car. They're going to work great in low vehicle productions like a Ferrari or a Porsche or something like that. Aluminums, obviously, you can do in bigger volumes. But when you get to the Chevy Cruisers of the world and those kind of cars, those are really tough to do at that price point with something as exotic as carbon fiber or as little available as aluminum may be.
You and I had a conversation here last week, and you cited 4 major ways to make cars more efficient and lighter. Talk to me about that, and then what your solution is.
Sure. So the general principle of meeting fuel efficiencies comes down to how do you do it, and there's 4 ways that most people look at. The first 2 are aerodynamics and reducing the rolling friction of a car. And those 2 have basically been kind of exhausted in terms of how much extra room you can get out of those or extra value you can get out of those. Unless we wanted every car to look like a Prius, it's going to be really tough to have a car that maximizes the aerodynamics the way a Prius does. And, a lot of people want trunks, and a lot of people don't want that shape. So those 2 have kind of been exhausted. So you're left with 2 more. And those 2 really come down to the powertrain and lightweighting the vehicle. Now, powertrains, we all know that's the hybrids, the batteries, the electric vehicles. So that's clearly one of the efforts afoot, and people are really trying to make that work. But you still can't get all the way there. As all of your listeners know, when you put an electric vehicle on the road, the first thing that comes to people's mind is what kind of range do I get? And, of course, if the car's lighter, I get longer range. So very quickly, you get down to the fact that if I really want to make efficiencies and the CAFE standards and the best way to improve that, I'm going to have to make the car lighter. And that gets back to using the different materials to make the car itself weigh less.
Now, the question becomes, how does NanoSteel make steel the best choice for auto manufacturers as opposed to, say, carbon fiber or aluminum?
Great point. So if you look at, if you want to make a car lighter, you've got a couple of options. You can use carbon fiber, aluminum, magnesium, steel. Steel has been the backbone of that industry for quite a long time and continues to be. If you look at carbon fiber, great material. It has some problems, though. It is not one easy to get. That's a real challenge in terms of availability. Secondly, it's not easy to use in a typical car because it takes quite a bit longer to make a part out of carbon fiber than it does out of aluminum or steel. And then third, and probably one of the most important for me and maybe for your listeners, is that if you have unfortunate times of an accident with a carbon fiber-based car, the only way to really inspect that, to find out that the carbon fiber part is good or bad, is to X-ray it. And you can imagine every local mom-and-pop garage shop is going to have a real tough time buying an X-ray machine, learning how to use it, and then replacing the carbon fiber pieces because you can't just bend them back on a frame machine. You got to really actually replace every piece.
Excellent point.
So that's a challenge that's a considerable challenge with carbon fiber. when you look at, so let's say, magnesium, because there's another one people talk about. It's used in Ferraris. It's used in quite a few cars, actually. But it has its challenges in terms of availability and usability in the production side. And so that's something you always have to consider. It's how do you use it to make the car, and then how do you use it to repair the car. Magnesium has a difficulty with respect to how to use it in the make the car side of it, and also, quite frankly, the availability of the material itself. And then you get to aluminum. Aluminum, obviously great material. Lots of people use it, and it will continue to become more and more important in automotive. The issue really comes down to the price point. At what price point can you afford to use aluminum in your vehicles? And as it stands today, there's a limit to that. And that's where you're left with, okay, I can't use aluminum in every application, and it doesn't really work in every application. And so you're left with, by default, steel. And
gotcha.
So when you look
now,
at, I'm sorry,
go ahead.
I was going to say, when you look at steel is pretty an amazing material. Personally, I've only been steel for about 10 years, and I always thought that steel was steel. You don't think much about it, but in fact, more than half the steel that's in a car today literally did not exist 15 years ago. So that industry continues to evolve itself, continues to try to meet the challenges that the automakers have placed on it. And what NanoSteel does is really evolve it to that next level. So when you look at steel, what the basic premise is that the stronger I make it, the thinner I can use it. So if I double the strength, I can almost cut the gauge in half. And in a typical car today, most of the steel, more than 90% of the steel, is less than the thickness of a nickel. So you think about that next time you're driving down the road. A nickel is a pretty thin piece of metal. But the goal for lightweighting is to try to get to, say, the thickness of a dime.
Wow.
And the only way to do that, make the steel stronger. That's what NanoSteel does. And it's not that the steels today aren't strong enough. The problem has always been the trade-off, because nothing comes free. And the trade-off with making steels stronger historically has been what's called elongation, the ability to basically form the part, bend the part. So what NanoSteel does in its simplest form is basically create steels that have really high strength, but also really high formability, really high ability to actually shape. That's the thing that's been missing in the steels of today.
Now, excellent point. Now, when do we see NanoSteel debut in cars? I think that's the question, because everybody is obviously looking for it. And, the industry is going in a direction now with I drove a Ford C-Max hybrid vehicle yesterday. And, like you said, it was Prius-like in shape and size. Now, ideally, I would like to be able to drive this same car with the same technology, get the same 47 miles per gallon in a full-size sedan. When am I going to see this?
That's a great point. And I think, it gets back to, like I said, powertrains, lightweighting. NanoSteel itself, our plan, if you look at the kind of the roadmap for the technology and the product development, our plan is to be in cars for the 2015 or 16 model year. And it's quite frankly, that's what it takes to get new materials in. And obviously, when we say lightweighting vehicles, a really important point is that you can't lightweight a vehicle without maintaining or improving the safety. And so that's you have a material that may be great, but you're still going to test that thing, validate it. I mean, literally 16 ways to Sunday to make sure that you are not sacrificing anything on the safety side either.
David, I'm reminded of Star Trek, the Star Trek movie where Scotty came up with the transparent aluminum.
Yeah, that's my next project. Yeah, I mean, it really is pretty fun. I have to say that it's very rare in a time that you get a chance to make a significant difference like this in terms of not just a basic material like steel, but also in one of the most important products, certainly in the United States and certainly in the world, which is transportation. So if we can, at the same time, make cars lighter and keep them safe and introduce a whole new product to the steel industry, we're doing something right. We feel pretty good about it.
David Paratore, President and CEO of NanoSteel Corporation, thank you so much for taking time out of your schedule on a Saturday to be with us on America's Car Show. And I wish you the best in your development in the steel industry. It's exciting to see where you're going, and I look forward to forward press releases.
Thanks, Tom. Take care.
Have a great day. Bye-bye.